Example 9 talks of the function fx is defined by fx is defined by two parts, 5 minus 2x, and in this case x is less than 1, and x squared plus 3, and in this case x is greater than or equals to 1. This is an interesting function because it is defined by two functions in one. And this is an example of a piecewise defined function. And piecewise defined function is a function defined by more than one equation. And you can see here we have two equations, one linear and one quadratic. So the first part of the question is sketch y is equal to fx and state the range of fx. Sketching this one, we need to simply have, we need to sketch this in the same set of axes. And we can already see, let's see what happens here. If we need to plot the first one, 5 minus 2x, when x is 0 in this one, you're going to have y is equals to 5, 5, 4, 3, 2, 1. When x is let's say 1, 2, 3, 4, 1, 2, 3, and 4. When x is 1, then you're going to have 5 minus 2, which is a 3. 1 minus 2, which is a 3. When x is a 2, let's see what happens. 5 is y is 5 minus 4, which is a 1. And you're going to have a good equation, a good straight line. And how do you name this one? Y is equals to 5 minus 2x. That is one part. That is one part of the equation. And all of them, of course, they are going to be y is equals to fx, but specifically, this is the linear part of the function. The other one, when x is 0, and of course, I should have talked of something else because this part is not needed. Really, why? Even this part itself is not supposed to be shaded, because for this equation y is equals to 5 minus 2x, we are considering only when the values of x are less than 1. Even when x is 1, we are not supposed to shade this one because x being 1 itself is not included. So when x is less than 1, then we can talk about all other values. Not when x is equals to 1 and not when x is greater than 1. That one, we have overlooked it, but now it's corrected. Let's go to the second one. Only when x is 1 or anything greater than 1. So for this case, when x is 1, 1 squared is 1 plus 2, plus 3 rather, which is a 4. And because of this sign, which includes that particular point, due to greater than or equals to 1, then we have a shaded point there. When x is now, the next value of x is 2. When x is 2, we have 4, 2 squared 4 plus 3, which is of course a 7. So we are going to have kind of an escalated kind of graph that moves that way because it becomes exponential as x increases. But most importantly, this is the part that we need because it can go as much as wherever, and this one can increase as much as wherever. So we are interested in that particular part. And let us just answer part A of our question. So part A of our question talks of sketch the graph of y is equals to fx. So this is y is equals to the function of x, both of them. Of course, specifically, you may call this one a specific name, and you're going to have y is equals to x squared plus 3. But both of them combined, they make the function of x. But let us answer the question and state the range of f. We have sketched what is the range. What is the range of the function of x? What is the range? We have to be very careful here. We have to be very, very careful here. Because as far as the linear graph is concerned, we have the range, not 3, but something greater than 3, because 3 itself is not included. You can see we have not shaded that point. But for the function, quadratic function, the range starts from 4 increasing. This other graph, the linear graph, the range starts from something greater than 3 and increasing. So the range is supposed to capture all the values of y that make sense for both of the functions, that make sense for both of the equation. So if we say that the range of x is 4 and anything more than 4, then we will have ignored this part of the linear part, which is also making sense. So the best answer to this question is that the range of fx is something greater than 3. You can already see between 3 and 4, there is a gap. But if we started from 4, then we will ignore the values of y for the linear equation, which are beyond 3 and less than 4. So the best answer to this one is the range of fx is greater than 3 because it captures all the solutions. Part B, what about part B? Part B of the function talks of solve fx is equals to 19. Solve fx is equals to 19. You know what that means? This means that for both of the equation, the range is 19. So we just have to compare. We just have to pick each and every equation here and equate it to 19. For example, the linear part is going to give us 5 minus 2x is equals to 19. Why are we saying that? Because as the linear part increases, you can never tell where it goes. Of course, 19 will be somewhere here, and we'll have a specific value of x, which gives us the value of y equals to 19. This gives us something to do with 2x is equals to minus 2x is equals to minus 14, because of 5 minus 19 is minus 14. And in this case, x becomes a good -7. That is the solution for the linear part when the function of x is equals to 19. The quadratic part, we should also be able to talk of the quadratic part. We are going to have x squared plus a 3 is equals to 19. And it goes without saying, x squared is 19 minus 3, which is 16. And getting the square root on both sides, you realize that x is equals to plus or minus 4. But be very careful. This is true, yes, but be very careful when giving any of these answers or both of those answers. You need to consult the domain. You need to consult the domain. And because our domain talks about x has to be greater than or equals to 1, then x cannot be -4, because we are restricted there. We have restriction. X can only be +4. And you can see 4 will give us 19. That means what? Even in the linear part of the function, when x is negative 7, again we will have to refer to the restrictions of the domain. And because in the restriction x is supposed to be less than 1 and 7 is less than 1, then we are very much comfortable with that. If we can just sketch this kind of a graph when x, if we put negative 7 there, just allow me to confuse it just a little bit, and x is equals to 4. When we are talking about 7, negative 7 there, we will have to assume that we have arranged. So this graph continues to and cuts when we are having 19, so we are supposed to have 19 there. So when x is supposed to be in a minus 7, then the y is 19 on the linear part. When x is supposed to be 4, then the y is supposed to be 19 on the quadratic part. That is exactly what is supposed. And you can see this is many to one mapping. All right.